This is 5.1, or 5.5, I'm sorry, lesson 1. And for this lesson, we are going to connect break-even problems with systems of equations. Okay, so I give you the situation where it says a school theater group is selling candy to raise funds in order to put on their next performance. The candy cost the group 20 cents per piece, plus there was a $9 shipping and handling fee. The group is going to sell the candy for 50 cents per piece. How many pieces of candy must the group sell in order to break even? Okay, so we have two different things going on here. We have the expenses that the group has, and we have how much they're selling it for. So our expenses, we have 20 cents per piece. Again, we see that word per to help us out where our rate of change is. And then there's a $9 shipping and handling fee. Okay, that's our one-time fee, that's our backup. Then we have how much we're selling the candy for, and we're selling it for 50 cents per piece. Again, we get our rate of change. Okay, so whenever I ask this question, break even, this happened when our expenses equals our sales. So we've done a problem like this before by setting up an equation where we put the expenses on one side and the sales on the other. Okay, so our expenses read 0.20p for pieces plus 9 equaled our 50 cents per piece, where p is our pieces of candy. And usually we solve this equation by subtracting 0.2p on both sides, dividing by 2, and getting, or dividing by 9, I'm sorry, dividing by 9, and getting 30 pieces of candy to break even. We've also done it with a table, where I do our pieces of candy, we figure out our expenses based on our pieces of candy, but we also figure out our sales. And we see that we break even at 30 pieces of candy because our expenses equal our sales. Okay, so we've done it from an equation, we've done it from a table, so now we're going to do it from a graph. Okay, so with our graphs, we now have two variables rather than one variable like we had in our equations before. P is still going to represent our pieces of candy, but the variable that we are missing is our D, and that's going to represent dollars. So we have our first equation, which represents expenses, and we have D equals 0.20p plus 9. It looks just the same as up here at the top. We just put a D equals in front of it. Okay. Same thing happens with sales. Sales are D equals 0.50p, which looks just like our sales part of our equation before. We just have a D equals. From here, we can graph these. Okay. Now, with our slopes, normally we don't want to keep this as a 0.2, okay, or 0.20. 0.20 is the same thing as 20 over 100 because it's 21 hundredths. If we were to simplify this, we could start by canceling zeros to get 2 over 10, which is 1 over 5. Okay, so that could help us a little bit better with our slope. We can do the same thing with 50 over 100, which is 1/2 for our slope. Now, I've already graphed this for you all, okay, with our expenses being the dark line and our sales being the dotted line. Okay, so step number 1 says on the graph, circle the solution to the system. Our solution is where the two lines intersect, and we see that they intersect at this point right here. Okay, we also know that this point is the point 30, 15. Okay, so number 2 says compare the system method of modeling to the equation and table with which we started. What is the advantage of having a graph? Okay, so a graph is going to be a quicker, more visual way to see when the expenses are going to be the exact same as the sales. Okay, so it's a quicker and more visual way to see when expenses equal sales. So number 3 says the group must sell how many pieces of candy to break even? Well, we see our pieces of candy as our x-axis, which means that it's going to be our X. That tells us our number of pieces of candy, and in this case, it's going to be 30. Then it says they will have sold how much money worth of candy at that time. So our money, or our dollars, is our Y, and then it's $15. Number 4 says if the group sells 400 pieces of candy, what will their expenses total? So we know our expenses is our equation D equals 0.20 times our number of pieces of candy, which we know is 400, plus 9. So we're going to do 0.2 times 400 plus 9. That's going to give us $89. Okay, then it says what were their sales total? So we know our equation for our sales is D equals 0.50 times our number of pieces of candy, which is 400. That is going to give us $200. So what is our profit? Well, we know that our sales, we made $200, but we also had to spend $89 just to have the candy. So we're going to take 200 and we're going to subtract $89, and that's going to give us a total profit of $111.